Hello? Hello? Well, good afternoon. My name's Daniel Plaisted. I work at Microsoft on the .NET framework. Today we'll be learning how to create cross-platform apps using portable class libraries. One of the things I love about Microsoft is that I love software development and I love creating tools that help make software development easier. And as I was a .NET developer, I saw that with each new release of .NET, there were major improvements in what I could do and in my productivity with generics and then LINQ. And so that's when I joined Microsoft to be a part of that. Another thing I love about Microsoft is that we're starting to deliver a unified experience across these different platforms: the phone, the tablet, the PC, the Xbox. And it's not just about this design style, although that's part of it. It's also that these work together. You can have an experience that crosses from one of these devices to the other seamlessly. We've got Office and your Microsoft account and Xbox Live and Xbox Smart Glass. So you can move and bring that experience with you, whatever device or platform you're on. And so portable class libraries kind of tie into both of those things because they make life easier for developers and they allow you to deliver experiences that cross these platforms. So what we'll learn today is how to create cross-platform apps that take full advantage of platform-specific features while maximizing code reuse for the rest of your app. And when you're developing an app for more than one platform, there's two things you want to avoid, but they're kind of at odds with each other. You don't want to write the same app twice. You don't want to duplicate your work. But on the other hand, you want to create a really awesome app, and you want to take advantage of whatever features are specific to each platform. And so you don't want to write to the lowest common denominator. So how do you do that? Well, on the right here, we have 3 patterns that we can apply, and that really makes this a lot easier. So use portable class libraries for the code that you share. Use the model view model pattern to separate the code that you share from the code that's platform specific, and use the abstraction pattern to call from the portable code into the platform-specific code. And we'll go into detail on these. There have been a couple of other sessions that have touched on this a little bit. And actually, each of those sessions was given twice. There was a session, How to Leverage Your Code Across Windows Phone 8 and Windows 8 by Andrew Byrne and Doug Rothhaus. And that covered the basics of these things. We'll go into a lot more depth on portable libraries and lots of different ways we can apply these patterns with lots of different samples. And then there was another one on basically XAML, really, across these platforms, which just touched on code organization and view model. But it was mostly about Blend and the designer in Visual Studio. Like I said, we're going to go into a lot of depth on these things. On portable class libraries, we'll cover the basics of the model view model pattern. And then we'll see lots of applications, and we'll talk about IOC and version of control. We'll talk about how to handle navigation. We'll talk about how to connect to Azure Service Bus, how to do an eventing model to sync your state across multiple devices. So there's going to be a lot of things we'll cover. And honestly, you don't need to follow all of the things we'll get into. This is the core. This is what you need to know. And when you apply these patterns, you'll be well on your way to developing cross-platform apps. And they'll cover 90% of the problems that you'll hit. So .NET has been a pretty successful platform over the years. And there have been a bunch of different incarnations of it. And that's been great as a developer, because as a .NET developer, I know lots of things. It's pretty easy to get into Silverlight or Windows Phone development, because most of the stuff I know already applies. C#, the base class libraries, XAML, LINQ, etc. So that's been great. When you actually wanted to write an app that would be on more than one of these platforms or share code in some way, it was still okay. But it wasn't the smoothest experience. And that was because you had to create a separate project for each platform that you wanted to target. And you could share the code via linked files between them, but you still needed to keep the project files in sync. And there were some parts of the experience which weren't great. The IntelliSense would be for a specific platform and wouldn't know anything about the other platform. And refactoring sometimes wouldn't work. And so this is an example of an open source library where there's really just 3 libraries, but he's got some of them repeated 7 times for different platforms. So that's not going to be fun at all to keep those project files in sync. So I think we can do better than that, and that's what portable class libraries are. They let you create a project in Visual Studio, and you choose what platforms it will run on. And then you have one copy of your source code, one project in Visual Studio, and it produces one binary file which will run on all of the platforms that you chose. So what can I use from portable class library? So portable class libraries are going to be limited to this lowest common denominator between the platforms that you chose. So these are the kinds of APIs that you'll be able to use from a portable class library. But there's good functionality in here. You've got the base class library, you've got XML, you've got data contract serialization, WCF, view model support, link, XLink, etc. So you've got good basic functionality in portable class libraries. The kinds of things that are not available from portable class libraries, a big one is anything to do with the user interface. You've got some view model support, but anything UI specific is not going to be in portable class libraries because that's different on each platform. There's no file I/O access. You can access streams and stuff, but to actually open a stream, you need to use a platform-specific API because those are different across the platforms. And then finally, any sort of interaction with the OS will not be in a portable class library. So, bringing up a file open dialog or sending a mail, opening a picture chooser, those kinds of things are functions of the OS. They're platform-specific. And also your app lifecycle. Starting up the app, shutting down the app, handling tombstoning, those are also platform-specific. So let's look at our first demo. And I'm going to have several different demos of different types of apps. This first one is going to be the fun one, I'd say. And it has to do with this. And I believe it'll come into focus. Oh, well. This is a puzzle, and you have to slide the pieces to get it apart. And it's actually fairly difficult. But the nice thing about it is you just have to slide the pieces. You don't have to autofocus. There we go. You don't have to rotate them or anything. So it's pretty easy to write data structure that'll store the state of this, and then an algorithm for solving that. And so that's what I've done here. So we can see the puzzle on the phone. We can rotate it around. And then in the background, it's, if I can tap the right button. There we go. So in the background, it's looking for a solution. And then when it gets done finding the solution, it would show it to me, and I could step through it. So this is a portable class library that I've written with the logic to solve the puzzle. And then I've written on top of that a phone app to display it. And I also have that for the PC. So we can just look at that. So here I have this for the PC, and you can see it's solving it quite a bit faster. I can do all the same things with it, and when it gets done, I can step through and it'll show me how to solve that. So this is the project in VS. And so we can see that I have a portable class library here with basically the puzzle, the state of the puzzle, and the algorithm to solve it. And then I have a phone app and a Windows app which reference that and have kind of the presentation, how to display it on the screen, and how to respond to input. So this was kind of a simple app, and there was a pretty simple separation between the portable code and the platform-specific code. The algorithms, the data structures, that's stuff that's really easy to put in a portable class library. For kind of more traditional apps with a user interface, the model view view model pattern is a great pattern for designing those apps. And what it does is at the base, you have a model. And this is data objects, business logic. It can be connecting to a service in the cloud or on a server or something to get data. But it's stuff that's not directly related to the user interface of your application. And then on top of that, you build view models. Now, these reference the models, and they are directly related to the user interface. They encapsulate what should be displayed on the user interface and kind of the flow of interaction of your app. What can I do? How can I move from one page to the other? What commands do I have? But they don't say anything about how that information should be displayed. And that's what you have the view for. The view is written in XAML, and it data binds to your view models to get the information that should be displayed. So if you think about this from a perspective of a cross-platform app, the UI should be platform-specific because I've got different screen sizes, different styles of UI for each platform. So I want to have a custom view for each platform. But in many cases, the flow of interaction and the what of the information that I want to display can be the same. And of course, the models can also be the same. So you can have your view models and your models be portable. So once you do that, you have a project structure that looks like this. You create a portable class library project with your view models and your models. And then for each platform you're targeting, you create a project for that platform where you have your startup code and where you have your views. And each of those will reference the portable class library. Now, as you develop your models or your view models, you're likely to come into a place where I need to call an API that's not available from a portable class library. And, for example, file I/O. And that's where you use the abstraction pattern. So you create a portable abstraction, an interface, or an abstract class that encapsulates the functionality that you need. And then for each platform, you implement that and then pass it down into the portable library. So now we'll apply those patterns, and we'll create a simple cross-platform app. So I'm going to start Visual Studio here. So the app that we'll create is a Notepad app. So we'll be able to save and load very simple text files. So we'll call it Portable Notepad. And I didn't even choose a portable class library. So portable class library. There we go. And then we'll choose, what platforms we want to target. And we'll choose .NET 4.5 and Windows Phone 8 and Windows Store apps. And so we'll start by developing our view model. Now, we just want a simple ability to save and load text. So we'll have two text boxes on our app, which will be the name of the file and the contents of the file. And then we'll have two buttons, one to save and one to load. So we'll call it Notepad View Model. And so I said that the view models communicate with the views through data binding. And that happens through an interface called iNotifyPropertyChanged, so that the view model can let the view know when a property has changed. And usually when you're doing MVVM, you've got an implementation of that in a library that you use. So we'll just add some simple code for our MVVM infrastructure. So here we have a simple implementation of iNotifyPropertyChanged with some helper methods. And another way that the view models communicate with the view is through the iCommand interface. So we've got a simple implementation of that. So then we want to derive from the base class, so notify property change base. And then we'll start by creating properties that correspond to these text boxes that we want. So string file name, public string file name, get set. Oops. So here we're going to use the helper method in the base class, ref file name value. And you notice we're actually using this new C# 5 language feature. There we go. To actually use the caller info attribute so we don't have to specify the name of the property. So that will avoid typos or refactoring problems where we don't have to do that. And then the same thing for the contents, public string contents. Live coding is a bad idea. Okay. So we've got the properties that correspond to the information we're going to display. And now we need the things we can do, which are commands. So we'll write two commands, one to save and one to load. So void save is our first method, and then void load will be the second one. And two commands, public iCommand, save command. Okay, and then we need to instantiate these commands and hook them up to the save and load method. So we'll do that in the constructor. Save command equals new simple command save. So now we have everything that we need for our view to bind to our view model. We have our properties and we have our commands. We need to implement the commands now. And to do that, well, we have to access file I/O APIs. So we need to use the abstraction pattern. So we'll create an interface for file I/O. Public file storage. And we'll have a save and a load method. Now, since we're running on Windows 8 in the Windows Store apps, the file I/O APIs on that platform are async. So we'll make our methods here return task. So task string load sync task save file async. And now we need an implementation of that, so we take it in the constructor. And then we can use that in our implementations of the save and load method. So here we just call the method file storage.save file async, file name, and contents. And in our load method, however, we need to wait for this async operation to complete. So we'll make that an async method, and we'll use the await keyword. So we'll say contents, it's await. Okay. So that's it for the portable part of our app. This is the functionality of our app that we can share across platforms. Sorry? Okay. Thank you. I forgot to set the file storage. Now, fortunately, I'm just going to jump to the completed product anyway. So here we have the completed app. So we have basically the same code here. We can see that we did set file storage here. And we're also initializing these with some values. but this is the same code we wrote, basically. And then we have a Windows Store app, a Windows Phone 8 app, and a WPF app. And each of those references this portable notepad, portable class library. And each of these has a view, which will bind to this, this view model. And each of these needs to implement iFile storage. So, for example, on the Windows Store app, here's the implementation of iFile storage, which uses the WinRT file application data APIs. And then the view, for example, has the text box, which is bound through data binding. This means binds to the file name property on my view model, is what the text is going to be set to. And then we have two buttons, to save and to load. And we have two bindings, to the save command and the load command, which are those properties of type iCommand that we wrote on our view model. And so we can run this. Wrong screen. There we go. And so we see our simple UI. We can say, hello, build. We can save it. And then we can load it from the same file. And then we can just, real quickly run the WPF version. Or, sorry, the Windows Phone 8 version. Let's use the emulator I've already got running. No, there were deployment errors. Wait until it completes. Okay. So there we see same thing on the Windows Phone, and we have the same kind of thing in this project here, where we have a view, data bound to the view model, and we've got the implementation of file storage, in this case using isolated storage. So that's a simple example, but it shows all of the basic concepts that you need to know to apply this to more complex apps. The one thing I didn't show was how we hook up our view model. So in this app, we simply created in the constructor of the main page, we constructed our portable view model, and we passed in the implementation of our file storage directly. And then we set the data context, which the data context is what you use for your view model, and it's what everything binds to. So going back to our presentation. So one thing to note about this is here we passed our dependency in directly from the platform-specific code to the constructor of the portable view model. That's great in a small app. As your app gets bigger, you may want to use one of these other patterns. You can use a service locator or platform abstraction layer to access these platform-specific implementations of your abstractions from your portable code. Or you can use an IOC container to hook everything up. We'll see how an IOC container works in our next sample. For the platform abstraction layer or service locator, it basically looks something like this. So you would just put this class in your portable code with static properties for the abstractions you need. And then you just set them in your startup code, your platform-specific startup code, and then you just access them when you need them from the portable library. So I'm going to keep coming back to this slide a couple of times because, like I said, this is what I really want you to remember. So share code across platforms with portable class libraries. Use the model view model pattern because it creates this clean separation between your UI, which is platform-specific, and your models and view models, which can be shared in portable libraries. And then create your abstractions for your platform-specific functionality that you need to call from portable class libraries. You just implement those abstractions on each platform. And then you can use a service locator or an IOC container to hook up those abstractions as needed. So this next demo is called Contoso Help Desk. So this is kind of like a sample of maybe an internal enterprise application where you've got, your IT support, and they have these support tickets coming in that they need to manage. So if I run it on Windows Phone, I can see that here are my tickets. I can see the unassigned tickets, and I can see all tickets. And I can go in and see details about it, and I can change who it's assigned to. I can also Contoso. I also have the app here, and I can see the same thing. And the interesting thing here is that the data is synced between the apps, and we'll look at how that works. But if I just exit out of this here, and then let's go to the emulator, and let's assign a ticket to me. So we'll say assign that to Daniel. Okay, and we can see here it's now assigned to me. If I go back here, we'll see that when it starts up, you'll see that move. Probably. Don't know why that didn't move. Maybe the internet is not working. Oh well. So let's just look at how this works. So we've got the same kind of setup. Sorry. Got to open that up. So we've got the same kind of setup where we have a project for each platform and then a portable class library implementing the core of our logic. So here we have the core project, and we have a MetroStyle or Windows Store app project and a Windows Phone 7 project, both referencing it. And here we have several different pages, so we have several different view models. And likewise, in each of the apps, we have corresponding views. So there's a couple things I wanted to talk about for this app. Navigation, IOC, async, and Azure Service Bus. So this is an application that has more than one page, and you need to move from one page to the other. But that's something that is platform specific. And so how do you handle that? Well, that's just a special case of the abstraction pattern. So you create an abstraction that says, this is the functionality for how I move to another page, and then you call that from your view models. So what that looks like here is, let's go into the home view model. Okay. And we can see that when you say create ticket or login or edit ticket, we call this navigation service, and we say navigate to this view model. And of course, that's an interface that has, go here, go back, that kind of thing. And then we've implemented that for each platform. So for example, here is the navigation service for our Windows Store app. And it uses a frame to navigate from one to the other. Now, the interesting thing is that from our portable view model, we're passing in the view model that we are navigating to. So our navigation service needs to know, well, what view corresponds to this view model? And there's different ways to do that. You can do it by convention if you want. In this case, we've explicitly set up that link. And so in our application, for example, here's our startup code, which is mostly boilerplate. There we go. Here's our app-specific startup code. Where did we? I'm looking for the code that links these together. Here we go. Okay. register platform type. So yes. So here we're telling our navigation service, we're saying, well, the home view model is linked up to the home view. So then that service knows, well, when I want to go home, then I tell the frame to navigate to this home view. IOC. So here in this app, we've got a lot more types with a lot more dependencies between them. Let's just look at the home view model again. So this class needs a navigation service. It needs a ticket tracker, which is one of my models. It needs an event aggregator. And then, for example, the ticket tracker has its own series of dependencies. It needs the event aggregator again. It needs a current user and an image provider. So if we were to manually try to construct this dependency graph, it would be a little bit cumbersome and hard to maintain. And so what we've done in this case is we're using an IOC container. And that's basically a library that can look at an object and look at its dependencies and inject those dependencies into the object. So in this case, when you ask the IOC container for a ticket tracker, it looks at the constructor and says, well, I need these three things. So then I'm going to go recursively create those, and then I'll create this, passing in the arguments. And so here's where we're initializing our IOC container. And what we're saying here is basically, well, just usually with an IOC container, you want to register. You say, well, this is how you create this type. These are the types you create. When I need this interface, supply me with this type. So this code is basically just saying, well, look at these portable assemblies and just find everything in it and register those. And then for the platform-specific code, we did something a bit different where we registered the things explicitly. So we said the Metro-style image provider, for example, provides this interface. So whenever this home view model, or the ticket tracker, needs an iImage provider, well, then we've registered here that you can get an iImage provider by creating this class. And then back in our application, for example, we start up the app by resolving the navigation service. So that says, create me a navigation service, and of course, recursively satisfies its dependencies, and then we just navigate to the home view model. So the next topic is async. So when we want to save or load something in a Windows Store app, we have to use async APIs. And so that means that in a lot of cases, the APIs we expose in our portable view model also need to be async. So here's one of these interfaces, for example, iPersistent Storage, which returns a task of a stream to save or load. And because this is a Windows Store and Windows Phone 7 app, this used to be really hard because task was a type that did not exist on Windows Phone 7. And so it was very difficult to share the code that needed to use tasks for Windows Store apps and then Windows Phone 7. Fortunately, we've just released a solution for that called the Async Targeting Pack. So you can see I've installed this Async Targeting Pack, Async for .NET Framework 4, Silverlight 4, and Windows Phone 7.5. So you can install that via NuGet. It's microsoft.bcl.async, and it's currently in pre-release. So if you're looking for it here, you'll need to say include pre-release. But that adds task to Windows Phone 7, and it adds all the APIs needed for async and await support in portable class libraries targeting any of these platforms. So finally, Azure Service Bus. So I apologize that the demo did not actually show it, but this app does sync the state between the different clients. And it does that using Azure Service Bus. So stepping back for a minute, a pattern that is often applied in conjunction with MVVM is, can be called eventing, or there's some other names for it. Event aggregation, or the messenger pattern. And this is a way of decoupling the sender of a message from the receiver of a message. So when something happens, instead of calling directly into the view model or something that, or the model that may need to know about it, you send an event out of a certain type, and any item in the system can subscribe to an event. So that reduces your coupling. And so that's what we've done in this app. And if we go into the core, we can see that in the create ticket view model, for example. So when we create a ticket, we create this object, and our ticket tracker is the model that actually keeps track of these collections of tickets. But we don't actually call directly into the ticket tracker from this create ticket view model. We just create a new ticket. We create an event that represents creating a ticket, and then we publish that to the event aggregator. And then the ticket tracker subscribes to that event. Here it's subscribing to a bunch of different events, including the create ticket event. And that means that whenever anyone publishes one of these events, then the handle method will get called, and it can actually, add the event to the appropriate collection. And so why might you want to do that? Well, I said it reduces coupling, and that means that you can test these things more easily in isolation. But another thing that it lets you do is that if all of your state changes are happening via events, then you can serialize those events and send those out to other devices. And so Azure Service Bus is something that can help you do that. And the idea is that you've got this service bus in the cloud, and you can have multiple devices connected to it. And they can publish events, and those events will be sent to each device that's subscribed. And so, for example, you can have a phone and a tablet and another phone, and they can all be sharing data by publishing these events that will be sent to each device. And this architecture is described in this MSDN magazine article by David Keane. And he wrote an app called On Your Way Home. And really, this Contoso Help Desk app that we're looking at uses the same architecture. So we've got our event aggregator here, which basically lets us publish and subscribe to events. And then what we've done is, essentially, we're using Azure Service Bus as an event aggregator in the cloud. So this is kind of on our local system, what we do. And then in our Service Bus library, we link it we link our local event aggregator to Azure Service Bus. No, not there. There we go. And this is the class that does it. So this implements iEvent Handler. And so this means it's going to get all of the messages, all of the events from our local event aggregator, but then it also publishes them out to Azure Service Bus. And likewise, anything coming from Azure Service Bus will go through this object, and then it will publish it out to our local event aggregator. So with this kind of architecture, we can build a Windows and a Windows Phone app, and we can connect it to the cloud, and we can sync data between them. So that's pretty nice. But in a lot of cases, you want to target more platforms. And so what are you going to do if you also need an Android or an iOS version of your application? You can write in Java and Xcode if you like, but then you're back to, well, I'm duplicating work. I'm rewriting the same app multiple times. So what I think is a pretty good solution to that is to use these tools by the company called Xamarin, MonoTouch and Mono for Android. And these basically let you write C# code that will run pretty much as native apps on each of these platforms. And just like we're talking about, you want a platform-specific user interface for each platform, these tools let you use the native interfaces, the native user interface libraries from iOS and Android. So your application looks and feels just like a native app, but you can have this shared code across all of these platforms. And so we'll look at a demo of that called Twitter Search. Now, so here's Twitter Search. And you can see I've got a core library, and then I've got an app for the console, for Android, this is the iOS one, and then for Windows Store and Windows Phone 7. And if you look at these, it's the same kind of pattern where I've got my views in each platform-specific project, and I've got most of my logic in my view models, my models, shared across the platforms. Now, this demo comes from a sample for a library called MVVM Cross, which is a library which is specifically for creating cross-platform apps for iOS, Android, Windows Phone, and Windows Store. And so I took that and I just added a little bit of functionality to it to connect to Azure Mobile Services. So Azure Mobile Services provides different things, but one of the things it does is a really easy way to store data in Windows Azure. And so I took advantage of that to add some functionality to save the tweets. Now, the client library to connect to that is open source and was actually adapted by Xamarin to work on iOS and Android using their tools. And I took their source and I adapted it to use portable libraries. So once you've done that, this is actually very simple. You've got this mobile service table, which you just get, and then you can just insert something to it, remove something to it. You can look it up. And this tweet view model, for example, just has some properties in it. And it serializes that to JSON, puts it in a table in the cloud. It's pretty easy to do. So let's run it. So here we go. We can type in a search term or, get one randomly. And we can go and search, and we see our tweets. If we find one we like, we can select it, and we can favorite it. And then that sends that saved tweet, stores it in that table. And then so if we were to run this on Windows 8, we could see the saved tweets. And this is the one we just saved. And for example, we could unsave it if we didn't want to. And then finally, we've got the Android version. So mostly the same thing going on here. If you're actually doing Android development, don't use the emulator. Use a device, because this is pretty slow. But we can see we've got all the same data synced across our devices, in this case using Windows Azure Mobile Services, running on all of these platforms. So once we do this, what do we get? Well, we reduce the amount of effort that we have to do to create apps for these multiple platforms. And how much of a reduction actually is that? Well, people generally report 5 from 60% at the low end to 95% at the high end of their code can be shared between platforms. Just last week, I guess, Draw a Stickman Epic was released for Windows Phone, for Windows Store, for iOS and Android, and they share 95% of their code. So using these patterns, you can definitely reduce the work to write an app for many different platforms. But you can use abstraction, you can use MVVM, so that you can also take advantage of the specific features that a platform offers. Another thing I just wanted to touch on was that the demo I showed with the puzzle solver was written using XNA. And so there is an open source version of XNA that will let you port your apps to iOS and Android, but also to Windows Store. So XNA isn't by default supported in that, but you can use monogame to port your app to any of those platforms. And just kind of to prove it, last night, a friend on Twitter was able to port that app to an iPhone, and he said it took him 20 minutes. So here we see the same app running on an iPhone with 20 minutes of porting effort. So we're almost done, and we're a little bit early, which is great, because then I can take questions. Of course, this is the penultimate session, so all of these have already happened. But here's some related sessions. And then for additional resources, I had a whole bunch of them, so they wouldn't really fit on a slide, and you're not going to remember the links anyway. But maybe you'll remember this link. This will have links to the demo code, lots of more reading about portable class libraries, links to portable libraries that you can take advantage of when using portable libraries. So there's a couple of MVVM libraries, a bunch of different IOC containers that you can use. JSON.NET is a very popular library for using JSON in .NET, and it supports portable class libraries. Metrolog is just a logging framework. And Ubiquity is a new project which plans to provide cross-platform async APIs for stuff like file I/O and networking. So if that works out, that should be really useful. It'll mean that, well, I don't have to write as many of these abstractions myself. I can just use a library that already provides those. And so it'll make it even simpler. Thanks for coming out. I appreciate it. Please submit session evaluations. Last year, I gave a talk at Build to a very small room, which not many people could. It was like 100 people, but it wasn't big enough. And so I ended up getting 5 session evaluations, and one of them was just someone complaining that they couldn't get into the session. So anyway, I'd appreciate your feedback. And we'll have time for questions. Come up to the mics. Thanks a lot. I guess one other thing is that, if I can't answer your question now, I'd be happy to talk about it later. And the first slide has my email and my Twitter handle, so feel free to contact me through those.
Hi. I noticed that your navigation service, one of the examples, was on the view model. Mm-hmm. How do you deal with navigation service on different clients? The Windows Phone is not going to be the same as the Windows Store, and it's not going to have the same pages.
Yeah. So the code that sorry. I was going to repeat the question, but you've got the mic. The code links the view to the view model. That's platform-specific code. So in that case, for the Windows Phone app, I said, this Twitter view model is linked to this Twitter view. And then I did the same thing for the Windows Store app, but it was the Twitter view for the Windows Store, or the home view, or the edit view. Does that make sense?
Yeah.
And then, there's some platform-specific stuff for, well, how do I actually navigate to this page? So on Windows Store apps, you pass in the type of the page. And actually on Windows Phone apps, you pass in a URI. So that's specified differently when I'm registering them, and each of those implementations knows how to do that.
My question was more specific on a Windows Phone 8 might have a page where the Windows Store 8. A Windows Phone might have a page which might be the same one single page for multiple things in the Windows Store. So you just ignore it on the Windows Store?
So are you asking, like, if I have, like, just because the screen size is smaller, I'm not going to display as much information? I may
Yes.
Yes, that's a great question. And the MVVM Cross framework might be a good place to look, because he has, I didn't show it, but the iPad version of the Twitter search app, for example, it's got the search and the results in the same screen. So he shows some patterns for how you can deal with that. But generally, you may have some code which is conditional in your portable class library, but you should still be able to find a way to share most of the code.
Thank you.
Okay, so I'm writing SDK to be consumed by Windows Store apps as well as Windows Phone 8 apps, and not just for our apps, but outside, other apps. So basically, if I do a portable class library, I cannot rely on the consuming app to write some platform-specific code for me. So how do I solve that situation?
Yeah. So if you go here to the links, so I've got this blog post, which I haven't actually linked to yet, but I will. How to make portable class libraries work for you. So that covers a lot of the stuff I covered in this session, but it also talks about how you can make it easy to consume libraries, and how you can, how you can do light up or various other things to make portable class libraries that are very easy to consume, but can still access platform-specific functionality. One way to do it is you have the same separation of a portable library and a platform-specific library, and they'll both get referenced by the final app. And then you just do a dynamic load. Via assembly load, you load the platform-specific version, and then you create the instance of the adapter type, and then access that through an interface afterwards. And there's a couple sample there's a couple libraries that show how to do that. MetroLog is an example that shows that pattern.
So in that case, you can access a platform-specific library code from portable class library?
Yeah, it's just the abstraction pattern again, but instead of passing the implementation of the abstraction directly down from your app code, you can just write some reflection code to find that assembly, load that assembly, and then load a specific type from that assembly, which implements your portable abstraction.
I see. Is there any performance overhead?
I wouldn't. It's something you do once, right? So I wouldn't expect it to affect anything.
Okay. Thanks.
My question is about NuGet packages.
Yes.
For traditional NuGet packages, that if you have multiple versions of multiple platforms, they're packaged using different folders. How does it work with portable class libraries? Should you duplicate it, or you only have one?
So NuGet just released a couple weeks ago, version 2.1, which adds support for portable class libraries. And so you've got the lib folder with your different platforms. There's a format. It's like lib/portable-net45 plus Win8 plus WP8, for example. So you create a folder like that, and then you put your portable libraries in there. So look at the NuGet documentation for exactly how you do it. But,
okay, so there will be only one place. Like, you don't need to duplicate it.
You don't need to duplicate it. Now, for example, if you have a library such as MetroLog or something where you've got portable parts and platform-specific pieces, then you might put your portable parts in a portable library folder. And then for a platform-specific, you'd need to put both, because NuGet only ever gets the reference from one folder. So if you want to...
Okay. That was my next question, actually.
Yeah.
Because most of the libraries consist of both. So then I need to duplicate it in these different places.
Yes.
Okay, thank you.
Thank you, everyone.
Yeah, I had one last question. I took a session earlier this week about portable class libraries across Windows Phone 8, Windows Store, and they talked about the Windows RT components, and they showed some examples where you add in a link,
Yeah.
a shared link. How does that work with all this other sharing of code? And
Yeah.
portable?
So, add as link is really the traditional way to share code. And it's not as smooth. So portable class libraries is, ideally we'd like to replace that. But add as link does have some advantages. You can use conditional compilation, which can sometimes be a lot easier than abstracting out some functionality.
Right.
And you can use, platform-specific things like WinRT. WinRT currently isn't portable, so you need to create the abstraction somehow and put that in platform-specific code.
Okay.
But if it turns out that the code is really pretty much the same, you might compile it for each platform, but use linked files to actually share the code.
What would be an example of that, like checking the calendar or your contacts?
So any WinRT APIs that are shared between Windows Phone 8 and Windows 8 would be a candidate for that.
Okay. Is there a list somewhere where we can find that?
I don't know at the moment. Feel
Okay.
free to contact me later, and I can follow that up.
All right, thanks.
I had one more question.
Yeah.
So I keep on hearing that platforms, the Windows 8 and Windows Phone 8 platforms are converging.
Yeah.
So which direction the convergence is in? Like, will I get more bang for my buck if I write Windows 8 code or Windows Phone 8 type of code?
Well, I would recommend, using portable class libraries. And
You're sticking to the official story.
well, I mean, so what's your question really?
I mean, what will the convergence look like? Okay, so is it Windows Phone is going in Windows 8 direction, or it's other way around?
I don't really know that
Okay.
that I even know the answer. But as far as the portable library part of it goes, we're trying to grow more and more. More and more functionality should be accessible from portable class libraries as time goes on. So yeah, that's a good place to start.
From a .NET perspective, you're going to see convergence to Win8. From a .NET side, if you go and have a look at what's available in Phone 8, pretty much, it looks very much like .NET side on the Metro side. So you will see convergence from the .NET side to the Windows side of things. With WinRT, I can't answer that. But, at least from the .NET perspective, the VCL is very similar. They're practically, for most of the parts, apart from networking, they're practically the same. So,
You nailed it, except from the .NET perspective. I don't think we live in a world where Windows Phone and Windows 8 are the only ones.
yeah, but I'm just saying that because I work for .NET. I know. Yeah. I don't know what Windows is doing, so I can't speak for Windows. So
My point
Yeah.
being is, if you want to target everything, then this is the solution. If you want to target iOS, you want to target Windows Phone, you target Android, and portable class library seems like which is what it's trying to say.
Yeah.
Whether you go Windows 8 or Windows 8 versus Windows Phone.
Yeah, I think it's a little bit of a different question. But, as far as that, great answer, Dave. He is the developer who made most of the portable class library stuff work. But generally, if you write for Windows 8, the pieces of .NET that you use almost all of them will just work on Windows Phone 8. The convergence is for the .NET side is pretty close to being there already for Windows 8 and Windows Phone 8. And we did make some changes for Windows 8, Windows Store apps. We got rid of a lot of legacy and specifically chose, these are the APIs that you could use. So that's actually potentially a little bit more restrictive platform right now. And so you might want to target that because then you won't end up using some of these methods that aren't available on it.
We use HTTP client, web client heavily, and it was sort of a little bit disappointing seeing that those libraries are sort of separate right now.
Yeah, we know.
We're aware of that.
So, like, just a couple weeks ago, we solved the async issue. So give us a little bit to address the rest.
SDK that works on both just doesn't make sense right now.
Yeah.
So we are treating like a separate SDK.
Well, I mean, the base networking is, so, I mean, if you go through web request, web response, you can still use that. You just don't have the high-level web client or HTTP client concept. So the networking, you can use networking.
Sure.
You just can't use the high-level concepts yet.
Right, yeah.
Yeah.
Most of our code is like that.
Yeah, so, I mean, we're looking into it. We have heard a bunch of feedback around it, so, yeah. We just ran out of time. SQL CE.
Thanks, guys. Thanks.